Okay, we are starting chapter 2. Before we start chapter 2, we're going to review some radicals and how to simplify them. It will actually be more helpful for chapter 3, but I want us to be comfortable before we get there. Okay, so the first example, actually as a reminder, radicals are square roots. Eventually we'll learn things besides square roots like cube roots and fourth roots, but for now, the only radical we know is the square root. The square root of 36 is 6 because 6 squared is 36. Okay, if it's a fraction, if it's rational, you can still evaluate it in your head. So the square root of 9 is 3, square root of 49 is 7. And if it's a fraction, I normally consider the numerator and denominator separately. So one more perfect square. The square root of 1 is 1. The square root of 64 is 8. So my answer is 1/8. These are all rational answers. Okay, now here's some irrational roots. Okay, we have reviewed this before, but there's a couple ways to do it. How you do it's up to you, depends on how you are comfortable doing it. Okay, one way to do it would say, okay, the square root of 20 is irrational. Can I think of two things I multiply to get the square root of 20 such that 1 is a perfect square? So I would do square root of 4 times the square root of 5. The square root of 4 is 2. So simplified, I get 2 square root of 5. And some of you do that in your head. If you do a factor tree, it would be simple. You'd be like 2 times 10. This is 2 times 5. The perfect square is when something's times by itself twice. So the perfect square is 2, which goes on the outside, and then the 5 goes on the inside. However you do, it's up to you. Okay, for B, it's 5 times the square root of 99. So I'm going to do 5 times the square root of 99. Again, simplify it however you would like to. I'm going to make it 9 times 11. Square root of 9 is 3, root 11, but then I still need to times it by the 5. So 5 times 3 makes it 15 root 11. And if you do a factor tree, that's fine. If you do a factor tree, we end up with this step matching and then this step matching. Okay, let's do one more. 7 times root 24. And if you can do the square root of 24 in your head, simplified, I'm fine with that. It's 2 square root 6. What is that? 7 times the square root of 4 is 2 root 6, which gives me 14 square root 6. Okay, now in example 3, we're going to rationalize the denominator, which some people have done before and some people have not. I think you did it in geometry. Okay, for the denominator here, this is square root of 7 over the square root of 5. The square root of 5 is irrational, and often they do not want you to leave an irrational number in the denominator. So we need to make sure it's not irrational anymore. Now, before I even do anything, I'm going to look at 7 divided by 5 and see if I can simplify it. I cannot. Square root of 7, I can't simplify that either. Okay, this can also be written as square root of 7 over square root of 5. You don't have to rewrite it this way. Just know that square rooting the entire fraction is the same as square rooting each piece of the fraction. Okay, now the problem is that the denominator has a square root of 5, which is irrational. Okay, I want to multiply by something that will make the square root of 5 no longer irrational. Okay, the thing I'm going to multiply it by is the square root of 5. Okay, I'm going to tell you why. Okay, if I do square root 5 times square root 5, I get the square root of 25. The square root of 25 is 5. Okay, now if I multiply the denominator by square root of 5, I need to also multiply the numerator. Okay, even though this looks funny, let's bring down what we have. Okay, now if I do square root of 7 times square root of 5, since they're both square roots, I can multiply the radicands together. So 7 times 5 is 35, so this is the square root of 35 over the square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 goes down to 5. Okay, now the reason this is a better answer, because now in the denominator I have a rational number of 5. Square root of 35 does not simplify because it's only 7 times 5. So this is my final answer simplified, and the reason it's better is because the denominator is rationalized, or there's no square root on the bottom. Okay, let's look at the next one. Okay, 4 square root 3 over square root 2. This is already simplified. The only problem is there's a square root 2 at the bottom. Okay, to get rid of the square root 2, I'm going to multiply by square root 2. Okay, if you do it to the denominator, you need to do it to the numerator. Okay, let's see what's left at the top. I have 4 and I have root 3 times root 2. These multiply together because they're both radicals. They're both square roots. So 4 root 3 times root 2 is root 6. Okay, now in the denominator, I have root 2 times root 2, which is root 4. What's the square root of 4? 2. Okay, now this is a better answer because the denominator no longer has a square root. I should still glance at it and see if it will simplify more. Oh, it does. Look, 4 root 6 divided by 2 is just 2 square root 6. Okay, let's try C. Okay, it's 3 over square root 14. Denominators, or numerator's great, square root of 14. Does that simplify? 7 times 2? No, it doesn't. But I can't have it at the bottom because that leaves my denominator irrational. So I'm going to do square root of 14 times square root of 14. If I do it to the bottom, I do it to the top. Okay, now on the top, I have 3 times square root of 14. Now the 3 is rational, the square root of 14 is a square root. They can't multiply together, but they can go next to each other. So 3 square root of 14 is 3 square root of 14. Now at the denominator, I have root 14 times root 14. No, I don't really know what 14 times 14 is, or I don't really want to. But I know when I square root it back, well, actually I do. It's 196. Okay, what's the square root of 196 though? It goes back to 14. Okay, so you don't really need to multiply it out. If I do root 5 times root 5, I get 5. If I do root 2 times root 2, I get 2. If I do root 14 times root 14, I'm going to get 14. I don't have to do the middle step. Okay, even though this looks like a worse answer, it's a better answer because the denominator is no longer irrational and nothing else in here simplifies. Okay, now let's do a mixed fraction review because it is a little tricky figuring out what to do when. Okay, now when you look at them, first look and see if the fraction simplifies. It doesn't. And then look at the numerator and denominator separately to see if you can do each separate problem. So for A, can I do the numerator? Square root of 4? Oh, that's 2. What about the denominator? The square root of 9? That's 3. Done. Okay, so don't overthink it. Do what you can. Okay, so 5 over 36 does not simplify, so let's leave it alone. The square root of 5, I don't know the square root of 5. I'm going to leave it square root of 5. What about the square root of 36? 6. Okay, are we good? We are good because the denominator doesn't have a radical. And I simplified everything I could. Okay, let's look at the next one. Let's see. 12 over 49 does not simplify. Now look at the numerator. Can the square root of 12? I don't know what it is. Does it simplify? It does. What is it? It's 4 times 3. So this is 2 square root 3. And then on the bottom, square root of 49 is just 7. Let's keep going. 2/5, does it simplify? No. Okay, do I know the square root of 2? I don't know the square root of 2. Do I know the square root of 5? Oh shoot, I don't know the square root of 5. Okay, now because their denominator has a radical on it, I have to rationalize the denominator. Okay, what do I times by? Yep, the square root of 5. Do it on the top, do it on the bottom, do it on the top. Okay, on the top, square root 2 times square root 5 is square root 10. And on the bottom, if I do square root 5 times square root 5, I get 5. Okay, does this simplify more? No. This isn't a square root. This is not. You cannot divide them. Let's try E. Okay. 25 over 6 does not simplify. Okay. So let's do top and bottom. The square root of 25 is 5. Nice. The square root of 6. Oh, I don't know the square root of 6. Okay, can I leave it like that? I cannot because there's a square root at the bottom. So let's times by square root 6. Okay, if I do 5 square root 6, I get 5 square root 6. The denominator, root 6 times root 6 goes to 6. That's a better answer. I simplified everything I could and I rationalized the denominator. Okay, one more. Okay, let's see if the fraction simplifies. 12 divided by, oh, it does. 12 divided by 3 is just 4. So this is the square root of 4. What is the square root of 4? 2. Okay, so the answer to this one is 2. If you had done it by rationalizing the denominator and timings by root 3, you would have actually ended up with the same answer at the end. But if you can simplify it before you square root it, it can often make the problem easier. Okay, here's some mixed practice. Go ahead and try them. When you finish, unpause, check your answers. Okay, go ahead and check 1 through 6, and your work could be different, but our answers should be the same. because the simplified format is normally unique. Okay, go ahead and pause, and I'll do the next answers. Okay, go ahead and check your answers for the last problems. Check your fractions especially carefully. I know that your work could be different, but our final answers should be the same because the simplified expression should be a unique expression.